This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what does increased NADH and a D plus ratio in ethanol metabolism lead to? Answer: increased NADH and a D plus ratio in ethanol metabolism leads to inhibition of TCA cycle, leading to increased acetyl-CoA used in ketogenesis and lipogenesis, leading to ketoacidosis and hepatosteatosis. Question: why are females more susceptible to the effects of alcohol than males? Answer: females are more susceptible to the effects of alcohol than males due to decreased activity of gastric alcohol dehydrogenase, smaller body size, and lower percentage of water in body weight. Question: what is the limiting reagent in ethanol metabolism? Answer: NAD plus is the limiting reagent in ethanol metabolism. Question: how does alcohol dehydrogenase operate? Answer: alcohol dehydrogenase operates via zero-order kinetics. Question: what is the effect of increased NADH and a D plus ratio in liver and ethanol metabolism? Answer: increased NADH and a D plus ratio in liver and ethanol metabolism causes lactic acidosis, fasting hypoglycemia, ketoacidosis, and hepatosteatosis. Question: what is the preferred antidote for overdoses of methanol or ethylene glycol? Answer: fomepizole is the preferred antidote for overdoses of methanol or ethylene glycol. Question: how can ethanol be used as a competitive inhibitor of alcohol dehydrogenase to treat methanol or ethylene glycol poisoning? Answer: alcohol dehydrogenase has higher affinity for ethanol than for methanol or ethylene glycol, so ethanol can be used as competitive inhibitor of alcohol dehydrogenase to treat methanol or ethylene glycol poisoning. Question: how does disulfiram discourage drinking? Answer: disulfiram blocks acetaldehyde dehydrogenase, leading to increased acetaldehyde, leading to increased hangover symptoms, leading to discouraging drinking. Question: can you explain the process of ethanol metabolism and the effects it has on the body? Answer: ethanol is metabolized primarily by the liver through the enzyme alcohol dehydrogenase and aldehyde dehydrogenase, which converts it to acetaldehyde and then to acetic acid. The increased NADH and a D plus ratio in ethanol metabolism leads to inhibition of TCA cycle, leading to increased acetyl-CoA used in ketogenesis and lipogenesis, leading to ketoacidosis and hepatosteatosis. Question: what are the effects of ethanol on the body? Answer: the effects of ethanol on the body can include changes in behavior, loss of coordination and balance, impaired judgment and decision making, and difficulty with fine motor skills. Long-term effects can include liver damage, heart disease, and addiction. Question: how does decreased activity of gastric alcohol dehydrogenase affect females compared to males? Answer: decreased activity of gastric alcohol dehydrogenase means that less ethanol is broken down in the stomach, leading to higher blood alcohol levels in females compared to males. This, combined with smaller body size and lower percentage of water in body weight, means that females are more susceptible to the effects of alcohol. Question: how does NAD plus act as a limiting reagent in ethanol metabolism? Answer: NAD plus is a cofactor for enzymes that are involved in the metabolism of ethanol, such as ADH and ALDH. As more ethanol is metabolized, the NAD plus is used up and becomes the limiting reagent. This means that the metabolism of ethanol slows down as the NAD plus becomes depleted. Question: how is alcohol dehydrogenase's kinetic behavior important in ethanol metabolism? Answer: alcohol dehydrogenase operates via zero-order kinetics, which means that the rate of reaction is not affected by the concentration of substrate. This behavior is important because it allows the body to regulate the metabolism of ethanol, preventing the accumulation of toxic acetaldehyde and acetic acid. Question: can you explain the effects of fomepizole and disulfiram on ethanol metabolism? Answer: fomepizole is a competitive inhibitor of alcohol dehydrogenase, which means that it competes with ethanol for binding to the enzyme. This makes it effective as an antidote for overdoses of methanol or ethylene glycol, which are also metabolized by ADH. Disulfiram blocks acetaldehyde dehydrogenase, which leads to an accumulation of acetaldehyde and causes unpleasant symptoms such as flushing, nausea, and headache. This makes drinking less appealing and can discourage drinking. Question: how does increased NADH and a D plus ratio in liver and ethanol metabolism lead to lactic acidosis? Answer: increased NADH NAD+ ratio in liver and ethanol metabolism leads to lactic acidosis by increasing pyruvate conversion to lactate. Question: how does fasting hypoglycemia occur as a result of ethanol metabolism? Answer: fasting hypoglycemia occurs as a result of ethanol metabolism because of the decreased gluconeogenesis due to increased conversion of OAA to malate. Question: what is the effect of increased NADH, NAD+ ratio in liver and ethanol metabolism on ketoacidosis? Answer: the effect of increased NADH, NAD+ ratio in liver and ethanol metabolism on ketoacidosis is that it diverts acetyl-CoA into ketogenesis rather than TCA cycle. Question: how does increased NADH, NAD+ ratio in liver and ethanol metabolism lead to hepatosteatosis? Answer: increased NADH, NAD+ ratio in liver and ethanol metabolism leads to hepatosteatosis by increased conversion of DHAP to glycerol 3P and diverting acetyl-CoA into fatty acid synthesis, which combines with glycerol 3P to synthesize triglycerides. Question: can you explain the mechanism of action of fompizole as an antidote for methanol or ethylene glycol poisoning? Answer: fompizole works as an antidote for methanol or ethylene glycol poisoning by being a competitive inhibitor of alcohol dehydrogenase. This means that it competes with methanol or ethylene glycol for binding to the enzyme and slows down their metabolism, thus preventing the formation of the toxic metabolite formic acid in case of methanol or oxalic acid in case of ethylene glycol. Question: how does disulfiram block acetaldehyde dehydrogenase? Answer: disulfiram blocks acetaldehyde dehydrogenase by inhibiting its activity. This means that it reduces the activity of the enzyme responsible for converting acetaldehyde to acetic acid, leading to an accumulation of acetaldehyde and increased hangover symptoms. Question: can you explain how ethanol can be used as a competitive inhibitor of alcohol dehydrogenase to treat methanol or ethylene glycol poisoning? Answer: ethanol can be used as a competitive inhibitor of alcohol dehydrogenase to treat methanol or ethylene glycol poisoning because alcohol dehydrogenase has a higher affinity for ethanol than for methanol or ethylene glycol. By giving ethanol, it binds to the enzyme more strongly than methanol or ethylene glycol, thus slowing down their metabolism and preventing the formation of toxic metabolites.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the First Aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.